Hello students, welcome to preparation strategy and important concepts on compiler design. And myself Ramesh Masuna, I'm going to welcome you all for this session on behalf of engineering. Which topics it is to focus because from where questions are asking and from where we have to get a questions means untapped areas of a concepts, and that we have discussed in the preparation strategy. Now here in this today's session we are going to discuss about the important concepts in compiler design and where to focus and what kind of questions are possible to come, that we are going to discuss. Okay. As we have discussed that from the compiler design, you are going to get an average of 4 to 6 marks, from the subject. And this 4 to 6 marks, we can guess it, like from where questions are possible to come, we can guess it, this 4 to 6 marks. Almost 99% of the times we can guess what are the questions are going to come, because majority of the questions are repeated in compiler design. And because the trend has started of giving untapped areas, questions from untapped areas in 2021, so there is a lot of scope is there in a compiler design subject to get untapped area questions. That we are going to discuss. And also we are going to discuss what are the tapped areas, what are the untapped areas. And we'll take at least one example of each question, each topic, one question, and we are going to solve and we are going to revise that topic. And because there are 5 topics: lexical analysis, parsing, syntax directed translation, intermediate code generation, and code optimization. These are the 5 topics. Among all the topics, parsing is undoubtedly very important. And parsing having 3 subchapters: grammar, context-free grammar, top-down parsing, and bottom-up parsing. And from the other topics, you can expect 1 mark questions most of the times. And in syntax directed translation, you'll get 2 marks questions. Right. And very rare you are getting 2 marks questions in the lexical analysis chapter and code optimization chapter. In code optimization chapter, as I told you in the preparation strategy, in 2015 when syllabus is revised, this chapter is removed, and again in 21 syllabus is revised, this chapter is added. And one new concept which was not there in the previous years of GATE examination, that is live variable analysis, is also added as part of optimization, which was not there in the earlier GATE exams. Questions are possible to ask from the live variable analysis, and in 2021 one theoretical question asked. In 2022 no question asked on optimization, but problematic questions are possible to be asked. We are going to discuss such questions in this today's session. So we'll start with the first chapter, that is lexical analysis chapter. In lexical analysis chapter, you are getting questions such that they are giving some program snippet and ask to find how many tokens in the program. Consider the following C program code. Mostly you can expect C program only because C programming is part of the syllabus in the GATE examinations. So that you can expect some C program syntax, like a program may be given and asked to find number of tokens in the above program segment is. What is a token? Token is a logical unit of a program. Now here, how many tokens were there? Main, open, close, again open, int, a. This comma is also one token we call special character. Right. And this is 8, this is 9, this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, equal is 21, and open parenthesis is 22, 23, 24, 25, 26, and 27. And then printf is 28, opening parenthesis 29, and this entire thing which is enclosed in double quotes is 30, and comma is 31, this is 32, 33, 34, and closing parenthesis is 35. Just carefully count it. And how many tokens were there here in this program snippet? There are totally 35 tokens are there. This is very simple question and straightforward question asked in the previous year GATES. You will be given a program snippet, maybe either 1 or 2 lines of program snippet is given, or else complete program you can expect and ask to find how many tokens here in the programs segment. And possibility is there for asking this kind of questions as a numerical answer type question. So fill in the blanks questions are possible. And in GATE 2018, first time a question is asked in this way. They have given a pattern, they have given some pattern, right? And they have given some input string and asked to find which tokens are going to be generated. Like they will be giving the pattern of a token and input string and what are the tokens. Here, how to solve this question? Just check with an options. It is very easy. Instead of going in random way, check with an options. The question asked in GATE 2018 is the longest possible prefix that is generated by the token is going to be the output of this lexical analysis. But the question could be slightly different also. Maybe possible to ask. Look at a lexical analyzer uses the following patterns to recognize 3 tokens T1, T2, T3 over the alphabet ABC. And here these are the 3 patterns given. And question is note that X question mark means 0 or 1 occurrence of the symbol X. Note also that analyzer outputs the tokens that matches the longest possible suffix. Longest possible suffix. Similar question asked in 2018 that is prefix. As you know that prefix means the starting terminals. Suffix means ending terminals. The question is about which token stream is the correct token stream that is matching with the longest possible suffix. And this is an input sentence given and these are the options are given token streams and which is going to be the longest possible suffix. Suffix means we have to check the last token. These 2 have, these 4 have this one like T3, T3, T3. Right. And because token 3 pattern is something C question mark BRA whole star C and all the options have token 3 only. But how to answer it? But token 3 not compulsory that every token stream is going to have the same possible length of suffix. Look at for option A, token T1. What is the pattern of token T1? A question mark BRC star A. A question mark means 0 occurrence of A. BRC means 1B. Or C star means 2 B's and ends with A. This is token 1. And again token 2 is pattern is B question mark ARC star B. B question mark, so 0 occurrence of B, ARC star means 3 symbols and ends with a B. This is token 2. Now token 1 have the length 3 and token 2 have the length 4 and token 3, last token 3 is C question mark BRA whole star C, means at least 1 occurrence of C is required. That is matching with token 3. So what is the suffix? That suffix length is 1. But question is about longest possible suffix. Like in which token stream it is longest possible suffix is possible. So option A, the suffix length is 1. Now in option B you look at T1, this is T1. And again T1 means A question mark BRC star A. A question mark BRC star A means up to this only. Now token 1 is of length 3, token 1 again is of length 3 and token 3 C question mark BRA star C, so length is 2. So because here the suffix length is 2, so option A is wrong because longest possible suffix is given. For option A suffix is of length 1, in option B suffix is of length 2. In option C T2, T1, T3, T2 token. Now T2 token B question mark, so 1 occurrence of B. T2, right? B question mark, ARC star, ARC no A, no C and B. So what is the length of token 2? Now here it is 2 and then token 1 after this token 1, A question mark, A already there, BRC star, BRC star, so neither B nor C but ends with A. Now here it is of length 2 and token 3 from this onwards. That C question mark correct, BRA star and C. Now length is 4 because C length is 4, option B is incorrect. Because option B is incorrect, because option C has longest possible suffix 4. Before we conclude with an option C, we'll check for the option D. T3. Now what is T3? C question mark, BRA star C, C question mark, BRA star C. This is T3. Now this is of prefix 5. And then again T3, C question mark, 0 occurrence of C, BRA star C. Now here it is length 3. Now suffix length is 3 here and here it is 4. So option D is wrong and longest possible suffix is C. And in the previous gate, the question asked is longest possible prefix. Now question could be like suffix also. This could be a possible type of question, or which of the following is the correct token stream. That also will be a question. So if all are correct token streams, and if it is given as MSQ, all options are correct, right? So because if it is prefix is asked, longest possible prefix, if asked, option D is the correct answer. Longest possible suffix is given as a question, then option C is correct, right? Find the difference and observe how questions are asking. That is important, okay? And next, when we go for the next chapter, that is context-free grammars, right? In the parsing, we have 3 sub-chapters: context-free grammars, top-down parsing, and bottom-up parsing. So one important thing that is possible to ask is, they may give you a grammar, and there are giving set of strings, and find the number of derivation trees of a string generated by the above grammar. So means here these are the 4 strings are given. Among the 4 strings, which string is going to be generated? And for the string generated, how many derivation trees are possible? That is a question. Okay, if you can participate in the discussion. Just I would like to see, are you sending any, like, are you giving any messages? Right, you can give your answers also, right? So here I can see, here I can see your chart, I can see your chart, and you can give your answers also. I'll wait for you. Right, I think nobody is giving answers. So, but okay, good number of people are watching it. Just I am waiting for. Okay, any answers? I think nobody is given answers so far. Chalo, we'll look at what answers are possible. The question is, which string is possible to be derived? And for the string it is going to be derived, how many derivation trees are possible? Find the number of derivation trees of a string generated by the above grammar. Look at, for the first one, S tends to AB is possible. So it is going to generate A. And because it is started with B, this production is not suitable. And the first production is suitable. And then with the B, I have to get A. To get A using B, we have to apply A, B, B production. And look at each B production is going to replace with the B's. And with this B, again, I have to have A. So that to get A, we have only A, B, B production. The number of B's are increasing. Because number of B's are increasing, in the string, there are only 2 B's are there. But if number of B's are more, then the number of, because number of B's are more, but here in the input sentence only 2 B's, so this is not possible to be derived. And look at for this 2 A's, right? 2 A's are already generated using this production. After this, we required to have a B. We required to have a B because 2 A's are generated. To get a B using B, we have B or BS. if I use BS with S, A possible or B possible, with B, again A possible, because with capital A, small a's are possible, but there are no more small a's. So this is also not possible to be generated by the grammar. And look for this AAB, AA already generated. And to get a B, we have here two options, B or BS. Because two options, one option you make it BS, and another option you can make it B. Both are correct, ABB, and this B is going to become B. Alright, and with this S you have to get a B. To get B with S, we have to use BA production. So B possible to generate. With A we have A, with B we have B, so that everything is possible. So this is a correct string. And here AAB there with B, we have to get B. To get B using B, we have to use BS. Here we use BS. With the S, we have to get A. To get A, we have AB, and with B, B. So how many trees are possible? Like tree 1, tree 2. There are 2 trees are possible. That's it. This is a kind of question possible to ask. And in the previous gate also this kind of questions were asked, but long back, but in the recent years this kind of question not asked, but you can expect this kind of questions possible. So how do you answer this question? Systematic way you can answer this question. Systematically you can construct a tree and see how many trees are possible. Okay, right. Any doubts? I think nobody answered so far, right? And Sunil Perla, 3 strings. I think Sunil Perla, 3 strings is incorrect. Fine. Chalo. Without wasting the time, we'll go ahead with one more. Questions are asked based on the precedence and associativity of the operators. The precedence and associativity of 3 arithmetic operators in some programming languages given below. These are the 3 arithmetic operators, and the precedence and associative mentioned, the value of the expression. How do you do this? You can convert this expression into tree and evaluate it. That is one approach according to the parse tree. But because in the gate examination we want an answer for the question, how you are going to solve it is not important. So it is simple. Directly you can evaluate the expression according to the precedences and associativity. Highest precedence is given to minus, so 3 minus 6, that is minus 3, plus 2 minus 8. 2 minus 8, it is minus 6. Star 4, right? The next precedence will be plus minus 3 plus minus 6, minus 3 plus minus 6, it is minus 9 star 4, and lowest precedence is there for star, minus 9 star 4 is minus 36. This could be the answer, or else you can construct a tree and evaluate it, but we wanted an answer, so answer will be minus 36. This is a simple question. And so far questions are asked on follow set, purely on follow set, but not on the first set. You can expect a questions purely on first set. Indirectly, first and follow is used by many concepts, many parsing approaches, but exclusively on first set, no question asked. So you can expect a question on first set separately, but questions are there on follow set in the previous gate. Here consider the grammar given below. This is a grammar given, and determine the first and follow of A. First and follow of A respectively. What is the first and follow of A? Will you answer? Just I will wait for 1 minute. If possible, you try to answer it. Okay. Ashish Barge. Okay, good. Ashish Barge, minus 36 for the previous question. Good. Happy to see your answer. Fine. And please respond to this question also. Ashish Barge E. Okay, nice. Ashish. What is first and follow of A? What is first and follow of A? Look at first and follow of A. What is the first and follow? Look at first set of A. First of A is first of B. First of B is first of C. First of C is plus and id. Right? Because question is about first of A. First of A is first of B. First of B is first of C. First of C is plus and ID. And plus and ID is there in each option except D. D is incorrect. And because first of A is first of B is possible to become an epsilon, so that first of A is first of X. First of X is star and epsilon. So star also possible. Star is not there in this option. Sorry. Yeah, star is not there in this option and here in this option. So only one option is left, that is option A. A is the correct answer. This simple way. So whenever you are writing the exam and sitting in the examination hall, better try to eliminate the options. If you eliminate the options, you can save the time. That time will be utilized for some complex questions. And this is another type of question in the predictive past table, M of this grammar. The entry M of A comma A contains dash number of productions. How many productions are there in this entry? That is a question. Will you try? Will you try? How many entries are possible? Ashish Barge, you are right. And tell me how many entries are possible. Just I'll wait for 1 minute. Sunil Perla, can you explain once, sir? Okay, I'm going to explain it, don't worry. So what is the question? Entry M of A comma A. M of A comma A means parse table, A row, A column. In A row, A column, we write only A productions. What are the A productions? These are all the A productions. A tends to A, we write in the A row A column because first of A is A. So A tends to A will come. And this is going to be occur in the B column. And A tends to epsilon is there because whenever this A is becoming epsilon, this is starting with A because that is starting with A means first of capital A, small a is small a possible. So that capital A tends to capital A, small a is possible. And anyhow, B will not come in the A column and look for epsilon. A tends to epsilon, you write in the A row and fall of A column. And what is fall of A? What is fall of A? Fall of A is A, right? And because A is a starting non-terminal taller, that's it, na? So means A tends to epsilon, you write in the A column. Means A tends to epsilon, you can write in the A column. Means except A tends to B production, all the three productions you have to write in the A row, A column. So the number of entries are 3. 3 entries in this production. Okay. So who answered correctly? Ashish Barge. Very good. Ashish Barge. Excellent. Right. Look for this kind of question, and this kind of question started asking from 2020 onwards, GATE 2020 onwards. And before that, this kind of question not asked. Look at, they are given some grammar. And the question is if I0, state I0 is closure of S dash tends to dot S. What is S dash tends to dot S? S dash tends to dot S means we are able to derive some input sentence using S productions. What are the S productions? S tends to dot small a, capital B, small b, and S tends to dot small t. And that's it, no? That's it. Any other? Look at S dash tends to dot S. S dash tends to dot S. We have to write S productions, and both S productions are started with a terminal, so that B productions are not going to be added. Because B productions are not going to be added, the question is then the number of items in the set go to of I0 comma A. So question is slightly different. So how many items in this closure of S dash tends to dot S means 3. But question is go to of I0, this is I0 comma A, means if you move dot one position to the right with respect to A, how many items are possible in the state? That is a question. If you move dot one position to the right, A dot B, B, because dot capital B is there, Because dot capital B, we have to write capital B productions. Capital B, we have three productions. B tends to capital B ES, and B tends to dot S, and B tends to dot F. Because dot S productions, there are two S productions, ABB, and S tends to dot T, right? Any more items possible? No more. And this is the other state I can call I1 state. How many items are there in the I1 state? 1, 2, 3, 4, 5, 6. 6 items are possible. This is another question. Anybody answered? Oh, nobody answered. You should be quick, right? Fine. Previously, questions are asked in this way, like they have given grammar and asked to say what type of grammar it is. But now the questions you look at, the way of asking question is different, but same kind of question. They have given some grammar, and the question is which of the following statement are correct. Statement 1 says LL of 1 can parse all strings generated by the grammar. LR of 1 can parse all strings generated by the grammar. LL of 1, LR of 1. Okay. How do you see this? Is it LL of 1? Look, means we have to say that if the grammar is LL of 1, LL of 1 can parse all strings generated by this grammar. If a grammar is to be LL of 1, there will be no common prefixes. Means here we can see first of B intersection first of C. First of B intersection first of C. First of B is A comma B. Intersection first of C is B comma D. B comma D means B is a common. Because B is a common, in the common entry you have to write both the productions. So the grammar is not LL of 1. It is not LL of 1. If it is not LL of 1, we have to check for LR of 1. If it is LL of 1, it is already LR of 1. How to check for LR of 1? Construct LR of 1 items. A dash tends to dot A comma dollar, and dot A means A productions. A tends to dot capital B. A tends to dot capital C. For both of them, lookup is going to be dollar, and dot B means B productions. B tends to dot A. B tends to dot B, and for both of them, lookup is a dollar, and dot C, because dot C is their C productions. Dot D, and C tends to dot B, and for both of them what C follows dollar. So this is a lookup possible. And here at this point there are no conflicts, but when you move dot one position to the right with respect to B, you are going to get B tends to B dot comma dollar, and C tends to B dot comma dollar. It means both are reduced, right? Now both are reduced. This is reduced and this is also reduced, and both are going to be reduced in the dollar. Dollar means because both are reduced on dollar, it is causing reduce conflict. Because it is reduce conflict, the grammar is not LR of 1. Means the grammar is not LR of 0, not LR of 1. So which statements are correct? Neither statement 1 nor statement 2 is a correct statement. This way you can expect a question. Okay, on parsing. And similar questions on parsing, right? And there are questions possible on syntax directed definition and translation. And before that, if required, you can take a snapshot of this question. And simple, what you have to do, you have to find what kind of conflict possible in this. And this question is MSQ. Now, you can solve that MSQ and to find what conflict is possible here, given shift reduce conflict in LR of 0, in SLR of 1, LLR of 1, and LR of 1. So is it conflict or not? How do you answer this question? Can you answer this question? Will you answer this question? I'll check. This kind of question not asked before that. Just I wanted to see anybody is going to answer this question. So hardly I will give 1 minute of time only. And in the meantime, when I was explaining also, if you solve it, you can able to answer the question. Otherwise, you can ignore it. Shift reduce conflict is possible in LR of 0, SLR of 1, LALR of 1 and LR of 1. Any answers? Okay, so far nobody answered the question. Okay, chalo, I'm going to explain it. In the meantime, if you solve it, you can just put your answer in the live chart. So let us start with LR of 0. We'll start with S dash tends to dot S. And with S, we have S productions dot A, S tends to dot open, L close. And you don't get L productions in the first state because we don't have dot L productions in the first state. So no conflicts. With S, one item possible, with A, one item possible, with open parenthesis, S tends to open dot L close. Dot L means L productions. We have two L productions, dot LAS and S, dot LAS, and L tends to dot S. Because dot S is there, S productions, S tends to dot A, and S tends to dot open, L close. Right? And here also you don't expect any conflict. There are no conflicts possible. And check for movement on L, dot L, because with dot L we have two possibilities. S tends to open, L dot close, and L tends to L dot AS. But here you don't get any conflict. Here you don't get any conflict. Fine. Next, with S, only one item possible. With A, one item possible. With open, you will get the same. And with A, if you move dot with respect to A, what you are going to get? L tends to LA dot S. LA dot S, because dot S is there, S productions. What are the S productions? S tends to dot A, S tends to dot open, L close. And here, any conflict possible? No, right? Okay, no conflict possible. Done, right? With S, only one item. With A, only one item. With open, you will get that item. Any conflicts are possible? Which of the following is false? Question is about false. Because nowhere I am getting conflicts. The question is about false statement. Shift reduce conflict in LR of 0? No. And because no conflict is there, the grammar is LR of 0. If the grammar is LR of 0, it is also SLR of 1. It is also LALR of 1. It is also LR of 1. It means if the grammar is all LR of 0, SLR of 1, LALR of 1 and LR of 1, if there are no conflicts, because there are no conflicts in LR of 0, no conflicts in SLR of 1, LALR of 1 and LALR of 1, because question is about false statement. These are all are false statement. This could be one of the MSQ. Okay? Fine, hope you understood, right? Okay, if any doubts, please let me know. I will check it out. In the live chat, you can post your messages. If you have any doubt, I can answer that questions. Right. And those are the type of questions in the parsing chapter, which is important chapter. And next important chapter is syntax directed definition and translation scheme. That is syntax directed translation. Here in the syntax directed translation, we have to construct a parse tree for the given input sentence and find what output is possible. Okay. So this is a question, and how do you answer this question? Construct a parse tree for this input and evaluate the parse tree and see what output is possible. Okay, will you answer this question? And this is a regular question only. Just I am giving you answer. This is 2.25 is the answer for this question. Check it out. Better you take a screenshot of this question and you can answer it. And this is another question based on translation scheme, and these are the standard questions. Almost every year it is asking, almost every year. It is a question on syntax directed translation scheme. You have to construct a parse tree for this input and see what output is possible. Just take a snapshot of this question and you can construct a tree and you can able to find what output this translation scheme is going to print it. Okay? These are the regular questions only. Fine? And this is a new type of questions. Consider the following expression of C code. This is a C program code is given. Assume all the given variables are declared in the program. How many minimum variables are required to convert the above code into 3 address code? So convert this code into 3 address code. And we have discussed this kind of questions during the live classes, during the physical classes, and in the pre-recorded lectures also we have discussed. Just go through it and okay, we'll solve at least one question. And you tell me how many minimum variables are required for this question. I'll give you a minute of time. But nobody is responding. I'm expecting you to answer the questions in a quicker way. If you participate, it will give me a boosting. Just I'm waiting for your answer to read. Ashish Barge, Sunil Parla, AD, Srividya Naundla. Okay, and you are active but not giving answers. Right. How do you answer? First A plus B. In the result of A plus B, you can store, if you store into A, here A is used, so you cannot store into A. And result of A plus B, if you store into B, and again B is used here. So you cannot assign the result of A plus B into A or B to have a minimum variables. So better we can go with B star C first. B star C. And the result of B star C, you can store into C because C nowhere dependent. And the previous one A plus B dependent, here A is dependent and B dependent. So I cannot evaluate A plus B. This is called rearrangement. And the result of this is C. Now you can make it A plus B. You can store into B. This is B. Next B star A. This one B star A. You can store into B, not A, because A is dependent here. And finally, this is B, and this is C plus A. And C plus A you can store into C, right? And finally, B minus C, B minus C. C plus A, if you store into C, okay, hi, no issue. Then B minus C, you can make it into B. So how many minimum variables are required? What minimum variables are required? 3. What are the 3? A, B and C. Any other variable is needed? No. So the minimum number of variables needed is 3. Right, Ashish Barge, you gave answer is option D, but option D is not there here. Options are not given, right? Okay, given. Options are given. But you answered 4, but it is not 4, it is 3. Have you understood, Ashish Barge? Right, I hope you understood. Right? Okay. And similar questions are asked on SSA. And how do you do this SSA? You convert into min TAC. You convert into min TAC from min TAC to min SSA. So min TAC plus number of statements will give you min variables in SSA code. That we know it, and just now we have solved one question. Similarly, you can solve this question also. If possible, you can take a snapshot of it. You can try on yourself. You can able to get it. And questions are asked on DAC. The questions you look at. then the number of nodes into edges in the DAG constructed for the above block of statements. Number of nodes into edges. Previously questions are asked as number of nodes and edges. Now question is slightly different, number of nodes into edges. So how do you do this? You construct a DAG for this graph, for this TAC, and see how many nodes and how many edges, and nodes into edges is the answer. So look at P equal to Q plus R, create a node for Q, create a node for R, create a node for plus, and whose adjacent nodes are Q and R, first statement, and result is I am calling P. Okay, this is a P. Now P plus 1, node P already there, node 1 you create, node plus, and P plus 1, and name the node as S. Okay, done. Node for Q already there, node for R already there, and then node for plus with adjacent nodes are Q and R also there, and this is name the node as T. Now we can say this Q plus R and Q plus R is common sub-expression. And create a node for S. S is already there, node for T already there, and node for plus whose adjacent nodes are S and T, and name the node as U. Okay, this is a statement. Now create a node for T. Here we have a node T already, and create a node for U. U already there, node T there, node U there, and create a node plus whose adjacent nodes are T and U, and then name the node as V. Right? How many nodes we have? 1, 2, 3, 4, 5, 6 nodes. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. So 6 into 8, 48 is the answer. Okay? Is it clear? So how many nodes? 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7 nodes, na? Yeah, sorry. This is a 7 nodes. How many nodes? Okay, let me write. How many nodes? How many nodes? Number of nodes. 1, 2, 3, 4, 5, 6, 7 nodes. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. How many nodes into edges is 7 into 8, which is equals to 56 is the answer, right? So question could be slightly different. This way you can expect. And here questions are on optimization. In the given C code, which line is part of loop invariant code? Will you answer this question? Which is loop invariant code? Which is loop invariant code? Anybody answer? Ashish Barge, Sunil Perla, Srividya Naundla. Okay, answer it. Fine. What is a loop invariant code? Means the code that is not required to be present inside a loop is called loop invariant code. J equal to J plus I, X equal to Y star J. Now J equal to J plus I, is it a loop invariant code? No. Why? Because the value of J is going to be changed every time because the value of I is changing. X equal to Y star J, here the value of J is changing, here the value of X is also going to be changed. So means every code required to be executed for the number of times the loop is repeated. So that which is a loop invariant code? None is the answer. So you need to know what is a loop invariant code, then you can able to answer it. And here is a question, control flow graph. And question is number of nodes plus edges in the control flow graph. How to construct a control flow graph? You first identify the leaders and identify the basic blocks. First statement is a leader, go to 3. Target is a leader, go to 3 is a leader, go to 5 is a leader, go to 6 is a leader, go to 8 is a leader, go to 9 is a leader. Every target is a leader, and go to 5 is a leader. Okay, go to 5, go to 3 leader, go to 5 leader, go to 6 leader, go to 8 leader, go to 9 leader. right? And the statement immediately after go to is also a leader. This is a go to statement, its immediate next statement is a leader. This is a go to statement, its immediate next statement is a leader, already there. This is a go to statement, its immediate next statement is a leader. It is a go to, its immediate next statement is a leader. That's it. So how many leaders? 1, 2, 3, 4, 5, 6, 7, 8. 8 leaders means 8 basic blocks. Simple. And in a control flow graphs, we have a start node and end nodes. Means 10 nodes are possible. And edges also given, na? Okay, because edges is given, you have to understand the flow. Look at 1, 2, and 3 and 4 together is one block. 3 and 4. And 5 separately 1, 6 separately 1, 7 separately 1, 8 separately 1, 9 separately 1, and we have a start and end nodes. Right? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 nodes in the basic blocks, 10 nodes in the control flow graph. And understand the control flow. If P greater than Q, conditional statement. So first started, P greater than Q, conditional statement, and if it is true, go to third statement. If it is false, execute the second statement. And second statement is go to 5, so directly it will make a jump. There is no true or false, only one control flow path is possible because it is an unconditional jump. And from the third block, we have a go to 6. 3, 4 and go to 6, and here this is unconditional jump, so go to 6. And fifth statement is executed, and after executing fifth statement, see, after executing fifth statement, it is going to execute sixth statement because it is a continuation, right? And is it possible to go from 2 to 3? No, because it is a direct jump. Is it possible from 3, 4 to 5? Because from 4 it is a direct jump. So 3, 4 to 5 is not possible. But after executing the fifth statement, there is no jumping. Directly it is go to the sixth statement. And sixth is a conditional, x greater than t3, conditional go to. Conditional go to means true or false. Two control flow paths are possible. Go to 8, if it is true, go to 8. If it is false, next statement. And the seventh statement, we have only unconditional go to 9. So there is no true false, only one control flow path possible. And from 8th statement, there is no jump, it will directly go to the next statement. And from the 9th statement, return T1 means it is returning T1 and exit from the program. How many edges? How many edges? Start to beginning and last node to end is not considered as a control flow path. And that will be considered as a edge. See how many edges? 1, 2, 3, 4, 5, 6, 7. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many edges? 11 edges. Just check for one more time. How many edges? 11 edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. How many edges? 11 edges. Question is about nodes plus edges. Nodes are 10, edges are 11, 10 plus 11 which is equals to 21. So answer for this question is 21. This is another question. Okay. Hope you understood. Right? And questions are on gen and kill variables also, because so far it is not asked, but it is possible to ask. Gen and kill variables. Which are gen variables? The variables that are definitely used their values before its definition. Before the definition, it is using. And here is gen variables you look at. Gen variables are the variables that definitely use their values before its definition. So before definition of A is used, B is used. So we can say A and B are the gen variables. And here P is used, but P is used after its definition. But gen variables are used before the definition. So P will not come under a gen variable, and C, so P will not come and C will come because C is used, and C already used and Q already defined. So what are the gen variables? A, B, C. Because gen variables are A, B, C, in option A, B, C it is given and option D is wrong. And kill variables. What are the kill variables? There are set of variables that are defined their values before its use. Before use, and they have defined their values. Now the value of P is defined. P is kill variable, and Q, it is not used, right? Before it is used, it is redefined. It is redefined before it is used. So Q will comes under kill variable, and R is defined before its use. Before that, there is no use for R, and it is we can call kill variable. So what are the kill variables? P, Q, R, that is there in option B. So option A and C are incorrect. So what is the correct answer? B. And so far questions are not asked on, these probability questions are not asked on live variables. These are the possible type of questions. Okay, that's about the important concepts. So hope you have enjoyed the session, and I have covered every topic, and for every topic I have taken utmost care to explain at least one question. So hope you enjoyed it, and if any question is not understood, and please let us know, and we are going to help you definitely, and if possible you can watch the lecture once again so that you can able to understand the question. Okay, right, ACE having pre-recorded lectures, exclusive live classes, and quick revision course. Those who wanted to crack the gate in a short period of time, the quick revision course is very much useful for you. And we have a previous year gate questions, gate plus ISRO questions, and every ranker is definitely going to solve all PYQs. Solving all PYQs is mandatory because almost 80 marks of a paper comes from the PYQs. So we have pre-recorded lectures of all previous year gate and ISRO questions, and which that we are giving for you for the 2,000 rupees only. And if you use my code RMSH40, you are going to get 40% of discount. Okay, that is definitely useful module, and if 40% means effective price is only 1,200 rupees, and with this 1,200 rupees you are going to get a test series free of cost. So means test series generally it is 800 rupees, I think. So 800 rupees test series free you are getting means effectively you are paying for the previous year questions module, you are getting effectively you are paying only 400 rupees. With 400 rupees, you are able to get the solutions, detailed solutions of 2000 plus questions and 200 plus hours of pre-recorded videos of all subjects, including mathematics. So I recommend every one of you must go through this PYQ module, which is very cheaper and will be helpful for every GATE aspirants. And better use my code so that you can get the 40% of discount. And we have a GATE classes in Hindi also. Suppose you are a Hindi aspirant, like you are a GATE aspirant and wanted to learn the subject in Hindi. आपको हिंदी में पढ़ाई करना है, आप लेक्चर्स ले सकते हैं गेट हिंदी कोर्सेज. CSE भी लॉन्च किया है गेट हिंदी में, हिंदी लैंग्वेज, हिंदी भाषा में, ताकि आपका पढ़ाई होगा आसान, राइट. And we have a handbook which is consisting of short notes, formulas, and important formulas and placement questions also. And handbook is one of the important, it will be helpful for you for your GATE preparation. And finally, I will say only one thing: to win the race, join the ACE. And I will end up the session with a big thank you. Thank you one and all.